Hello and welcome to That's Absurd. Please elaborate. My name is Trace Dominguez, and that intro was so tight. And then I went and messed it up by talking about how tight it was. Anyway, if you haven't listened to our show before, this is a show about science things that we answer the questions that you send in. And by we, I mean me and the other guy who hasn't spoken yet, Julian ʀᴇᴜ. Hi.
That's Sorry, you. I was admiring your tightness there for a sec. So that's me. I'm the second one. Julian, hi.
The second one. Again, if you haven't listened to the show, we answer questions from you, the audience, and we do as much science research as we can. Those questions, usually ridiculous, sometimes off the wall, sometimes kind of normal, but mostly odd.
Yeah, absurd, one might say.
One might say. And then we elaborate.
Yeah.
Anyway. The first time that you're listening, I think you're going to really enjoy it. And let's be honest, usually we say the intros are better than this, but they're not.
Let's
go to our first question on this episode. Julian, who asked the first question?
My question this episode comes from Aaron, who sent in some audio.
Help! A mad scientist shrunk me down to about 1.8 centimeters tall and left me stranded in a random suburban backyard. What are the biggest dangers I'll face? What can I do to increase my chances of survival? Are the Honey, I Shrunk the Kids movie series and the video game Grounded good survival guides? Help me, Trace and Julian. You're my only hope. Thanks for taking my question.
I'm so glad he brought up Grounded because that was where my mind immediately went. Have you played the game?
No, I've not played it, but I've heard of it.
Oh, it's fantastic. I'm sure you've seen the Honey, I Shrunk the XYZ documentaries, right?
Yeah, of course. Yes.
Yes.
And also the blew up the one as well.
Yeah. So they get small and then they get bigger, and then I haven't seen the docs, but
yeah, they get small.
I've seen the shrunk one.
Yeah, the original shrunk one, they get very small and they're in their backyard. But then there's the blow up one, which at this point is really just a in memoriam for all of Las Vegas, because it turns out they get bigger if they're exposed to neon lights. So the little toddler just keeps getting bigger and bigger.
Wow.
And destroys the Vegas Strip, which of course doesn't look like that anymore.
The gets bigger when exposed to neon lights seems very like 1980s sci-fi logic to me. Like, how's it work? Who cares? Who cares? Neon's a weird bright color. Yeah. Whatever. It'll make you big.
That came out in 1992.
Oh, wow.
Honey, I Blew Up the Kid.
Have you ever noticed how the 80s sometimes goes into the 90s and like the 60s sometimes goes into the 70s? You know what I'm talking about?
I mean, the Blew Up the Kid was probably written in the late 80s because Shrunk the Kids came out in 89. So it would have been written in like the mid 80s because it takes a long time to make a movie. It does. Longer now probably, but.
And there's some cultural overhang, I think, from decade to decade. Okay.
Yeah, definitely.
We're dancing around the point, though. Let's get into the actual question.
Yeah, let's get into it. Let's just shrink down and focus.
Jump on in there. Okay, so as Aaron brings up, there's a lot of different times in pop culture when this idea of being shrunk down to a teeny tiny little size has been explored. And correspondingly, there's actually been a lot of times that people have speculated about what this would mean realistically, including our own friend of the pod, Joe Hansen of It's Okay to Be Smart. He had a pretty succinct and excellent video that talks about the challenges that would come with being shrunk down to Honey, I Shrunk the Kids sizes.
Okay.
So first off, if you just took a human with human proportions and just shrunk them down to about 1/100th of their normal size, right? I'm average height at about 177 centimeters, so down to 1.8, 100 times smaller. If you shrunk us down that much, it would get harder to see.
What?
Yeah.
I mean,
Surprised?
I mean, I didn't think about it, but it makes sense because your eyes are smaller.
Yep.
So relatively speaking, the wavelengths of light are bigger.
The issue really more is your eyes being able to dilate and let in enough light.
Oh.
So that you would be able to see. I guess we should back up more because here's an important question, and that is, are we taking everything that you are and making you smaller? Just like scaling it down? Because I think that's the assumption, right?
You mean like my shirt?
I mean like the cells and the molecules, right?
Oh. Like if I made my cells way smaller,
right?
It seems like that would be a problem.
Don't you think?
I mean,
right?
I do. I just mentioned it. But yes, I think it would. I have a feeling, yes. I think the answer to your question that you posed, yeah, I think you make your cells smaller. I think you make your shirt smaller. Whoever smartly asked about that.
Gotta have a correspondingly small shirt.
Yeah,
That's
small shirt.
Also,
it's and probably, you know what, just to keep it simple, maybe the shrink ray just like draws an egg around you and just shrinks everything in the egg. You know?
That's good. Yeah,
that
so
keeps it simple.
Whatever you can fit in the shrink egg
In the shrinking area.
it can get shrunk down, which is good because Aaron's asking, how do I improve my odds of survival, right?
Right.
So what are we going to bring in our shrink egg? All right. If you shrink
An
down...
unshrinking egg. I don't know. An unshrinking ray.
If you shrink down, but your eyes, proportions remain the same, yeah, apparently you're going to have difficulty seeing because you're just not going to be able to get as much light hitting your retina to actually excite those cells in the back of your eyeball and cause you perceive the world around you. That seems like a problem. So bring in the shrink egg, some night vision goggles.
Oh.
That's solution one.
Collect a bunch of extra light.
Yep.
Shoot it at your eyeballs on purpose.
Yep, that's what they do. They just take the light in the environment and they just ramp it up and then feed that into your eyes. So if you're looking around at night, you can see. Well, if you're also tiny and looking around during the day, it should help you see some more there as well.
Great.
Now, you might have an issue communicating with your full-sized humans that were left outside of the egg. Yeah.
Why?
So this actually has to do with if all the structures shrink, think about how your vocal cords work. Think about how your ears work, right?
Yes.
Inside your ear, you have those little hairs, and they vibrate with frequencies that make them vibrate, right? They have to be the proper length so the incoming air oscillations actually, they get your eardrum to vibrate, and then it shakes hairs inside your ear, and it triggers the nerves that they're connected to, and you can hear things. If they're shrunk down, that means the frequency range that you can hear goes up. The wavelengths that'll actually trigger these hairs in your ears to vibrate are going to go up.
Makes total sense.
Yeah.
Same thing that I thought was the problem with the waves, although not necessarily, is that the waves themselves are physical things. We don't think of them that way, but they are. The waves of sound and light are physical in many ways. And so if you have a really big sound wave and now I'm really small, it's too big for me to hear. But if I have a really small sound wave and now I'm really small, I couldn't have heard it before, but now I'll hear it.
Yeah, exactly. So with the eyes, right, when we're talking about wavelengths of light, that's a certain amount of energy carried by those waves that excites the cells in your eyes and gets them to react to that. And that should probably stay the same if you just take the exact same atoms and you somehow compact them down. Yeah, right?
Like Ant-Man. You're just shrinking the space between them.
Exactly.
Somehow.
Right? You should still be able to get the electron to respond to like that energy coming in from the light and excite and still respond. But it is more dependent within your ears when we're talking about the actual size of the waves. And so your hearing is going to shift from normal hearing range of 20 hertz to 20,000 hertz. Hertz is just oscillations per second. It should shift, and you shouldn't be able to hear anything below 400 hertz.
That's pretty low.
So 400 hertz is fairly high when we're talking about normal human speech, right?
Yeah.
When a human talks, like a typical male voice, that's between the ranges 85 and 255 hertz.
Okay. Or if you're me, it's more like way higher. Hey, everybody.
You'd need, if you wanted to hear somebody talking, you'd need some sort of device you'd need like a little computer with Pro Tools running on it to just pitch shift up
everything.
Whatever it is
everything you got. Just pitch shift it. You need one of those things from the kids' toy store. Then when you talk into it, it makes you sound like
a little chipmunk.
Like a little chipmunk.
Yes.
So everybody can hear you.
Exactly.
Well, hey, everybody, how's it going?
When you talk to anybody, you need it in the opposite direction, right?
You
need it to lower because your vocal cords will be tighter.
Yeah.
And so you talk in a really high-pitched voice. You'd probably talk around the edge of what human hearing is, around that like 10,000 to 20,000 hertz range with your teeny tiny little voice.
That's funny. Everybody
Yep.
would sound really weird.
It would. It'd be hard to hear them. And they're also being tiny. They're not moving very much air, so you're not going to be very loud. You're not going to have a big amplitude either.
Right.
Right? So you'd need a megaphone that also lowers your voice if you wanted a full-sized person to hear you.
Got it.
It'd be
Understood.
good not to get shrunk alone.
Yeah. Good thing in the documentary, it's a whole group of people.
Yes. So you wouldn't want to be by yourself. So bring a buddy into your egg as well, and some night vision goggles for them. And probably some coats.
Oh?
Yeah. Something really nice and warm.
Why is that?
Trace, what did we talk about? I feel like every other episode.
That I worked at the fort? I don't know.
No, not that one this time. That's every episode.
Katie is going to college.
Nope, but we do bring that up a lot. She's almost done. I'm very proud of her. No, we talk about the square Q law.
The square cube law. Yes.
Right? So when you shrink, your volume is going to get smaller at a much faster rate than your surface area. So you're going to have a lot of difficulty retaining heat. You're going to lose a lot of that through that relatively larger surface area. You're going to get cold really easily. So you're going to need something warm probably to insulate you. So bring a big, fluffy Canada Goose jacket or something.
Yeah, so fluffy.
So fluffy, like you're going to the Arctic. And probably a lot of food, because your metabolism, you're going to burn through a lot of stuff as waste heat. Yeah.
Interesting. Does that mean ants, it's colder for ants because they're little?
Great. Well, with ants, they're not endothermic like us. They're not warm-blooded. Their temperature is just determined by their environment. So that's not
So they're just
not an
cold.
issue for them.
They're either cold all the time or warm all the time, depending on whatever their environment is. Yeah.
They're not trying to regulate heat like we are. We're trying. Our body, right, has a homeostatic point where we're trying to maintain a certain body temperature where things are most efficient. And if we're losing heat to the environment because we're so tiny, we're going to burn a lot of energy just trying to maintain that temperature.
Yeah,
So-
that makes sense.
Aaron, bring a thick, fluffy coat.
Real thick, real fluffy.
But of course, we're all assuming that everything's going to, function when we're shrunk down. And I don't think
eating
that's a
and
good assumption.
stuff.
Yeah, eating, breathing, your brain working.
I would just assume that for some reason in my head, the air feels like you would breathe air and it would feel chunky. I don't know why. In my head, that's what it is. I'm putting it out there. If I were 1.8 centimeters, it's very specific, Aaron. I don't know quite why you picked it, but I feel like the air would feel chunky.
I think that's not the case, although a stiff breeze would be catastrophic if you were that tiny, right?
Okay.
You would definitely feel the effects of wind, air moving around much more dramatically than you do at your current size. My concern more is, okay, if we take these structures and we just shrink them down, they're not going to work anymore, right? The hemoglobin in your blood is not going to be large enough to actually accommodate the oxygen atoms that it grabs and moves around your body.
Really? Even just the macro, you're still macro. Relative to atoms, you're still giant. You're still humongous. But I guess if you shrink the atom itself, don't work no more?
And the molecule, right? Hemoglobin is like this crazy looking nest structure that actually has space for oxygen to attach to it. And if you shrink it down, it's not going to be the right shape anymore for the oxygen to actually snuggle on in there.
Yeah, it wouldn't want to cuddle with the hemo anymore.
How's it going to get in there? It can't.
It can't get in there. It's,
carry it.
Right now, the hemoglobin's the big spoon, and it just can't be the little spoon.
Yeah, you're right. That's the perfect...
oxygen doesn't want to be the big spoon.
It doesn't want to be the big spoon. And that's assuming that our lungs would still function. Veritasium recently did a video, too, related to this, where they talked about a Google interview question that's, by the way, one that's bothered me for years. I'm glad they actually made a video on it. We can get to that in a moment. But they interviewed Carl Zimmer, who's a science correspondent for the New York Times, and Zimmer says, I don't even think that your lungs are going to be able to function because they right now have a quite delicate balance in actually having the right pressure internally versus externally outside your body. And if you shrink them down, Zimmer doesn't think you'd be able to keep your airways open.
Because air pressure would be relatively stronger to your muscle abilities and like bone structures and...
Or just the little sacs, right?
Oh, just the alveoli themselves.
Yes, right? He just doesn't think that they'd be able to stay open. So you might need to bring some scuba equipment as well.
Wow. Oh my gosh.
Right?
Okay.
Like a canister of oxygen, but more importantly, that pressure regulator that scuba tanks have.
Yeah.
So when the strong outside environmental pressure, like it could regulate that and actually push it into your lungs still, push that oxygen in your lungs, you might need to do that.
Whoa. That's cool.
Yep, so we've got night vision goggles, giant fur coats, scuba equipment, and a friend. Oh, and a megaphone.
And a megaphone. and a voice changer of some kind.
A voice changer.
And lots of food.
You're like a little techno robot person at this point.
I mean, I have to say, it just sounds like you want to bring an Ant-Man suit.
Or a space suit.
Or a space suit, yeah. It's just, I always thought, in my head canon, the Ant-Man suit, they would only open the helmet in the movie for like, you've seen Ant-Man, the movie.
Yes, the documentary, yes.
The documentary Ant-Man. We've talked about it on the podcast before and how the physics of it doesn't make any sense and it's mostly magic, and that's fine. But the headcanon that I've always had is the reason that it's a helmet that completely covers your body and does all is because it's like shrinking the oxygen and like the air so that when you breathe in, it's just shrinking it so that you can process it. And when you breathe out, it's re-enlarging it or whatever. That was actually part of what, in my head, how the suit worked.
Yeah, well, based on everything we've talked about here, it would have to work that way.
Right, and keeping him warm makes sense. Okay, there's lots of little tubes on there, which is pretty common, especially in spacesuits. Underneath the spacesuit, in every space movie, they never put this on, but aside from the astronaut diaper, they have a water-cooled and heated system to make sure that you're the right temperature and stuff, and so the Ant-Man suit could have that. Doesn't solve the food problem, but I guess if you're keeping yourself warm, maybe you're avoiding that. I don't know. But anyway.
This might need to be a very short excursion to being tiny. Like the clock is definitely ticking.
Sure.
Once this starts. Again, assuming that you could survive, because Zimmer also doesn't think your heart would be able to provide enough blood pressure to move blood throughout your body and keep you alive.
Why?
He just thinks that the structure of the human heart, if shrunk down, would not be adequate to do that.
Amazing.
Yeah.
I mean, it makes sense. We're designed to be the size that we are, roughly. Millions of years of trial and error has gotten us to this size with this structure.
Yes, exactly. And not all covered in fur for insulation and so many other things, right?
Right.
I was thinking about food as well. We've talked about this with evil ʔᴏ in the Mirror Universe, how your proteins wouldn't be able to break down glucose. Same thing if you're really tiny, the proteins are not going to be able to break down full-size glucose. So keep it a short trip to the tiny realm. Aaron, I also think if our established rules are that you're taking full-sized human and just compacting it down, I don't think you're going to be able to move anywhere. At all. You just won't be able to move at all. Here's my reasoning.
So wait, you can't see, you can't talk, you can't hear, you can't process energy, you can't blood, you can't
blood,
can't move,
can't even blood. Okay, now
this is bad.
Here's why. Now, it depends on the approach you take. Veritasium, in their video, they were covering an old Google interview question. It was like a brain teaser that before they had more rules, you know how tech companies always start all fun and then they get not
less
fun.
Yeah.
Yeah, been there.
Yeah.
One question they apparently used to ask regularly in interviews was, all right, you're shrunk down to be about this size and you're inside a blender. And the blades of the blender are about to turn on. How do you get out?
I don't like it.
I don't like it either. But what do you think?
They're not on currently? Is there other stuff in the blender with me? Am I by myself? It's just me and a blender?
Just you and a blender.
How small am I? Can I just lay against the walls? Because the blender doesn't actually touch all the walls. It just goes through the middle.
Great question. I
would just cover my ears and duck. Like, I'm probably going to be fine. But if it's full of stuff, I'm dead.
It reminds me of the Emperor's New Groove documentary where Yzma talks about turning Kuzco into a little flea and then putting him in a box and putting that box inside of another box.
And then mailing that box to herself and then
smashing it with a hammer. Yes.
Or to save on postage. I could just poison him with this.
Right? Like that's, to me, it's like you've been shrunk down and then placed in a blender and the blender's about to turn on. It's just like,
were you
James
standing
Bond,
atop the blender prior to being shrunk?
It's James Bond supervillain levels of overcomplicated execution, you know? Like it's so needlessly dumb.
Especially if you can't breathe, can't move.
You're just inside this blender that somebody's about to turn on, who knows why, all right? And you have to get out or you'll die. How would you get out, was the question.
If it wasn't on, maybe I would just stand on one of the blades, and when it turned on, it would fling me out. And
I love
Ant-Man
that idea.
style, I'd be fine because I'd still be very dense.
Yes.
So it would probably be fine.
Yeah. The
Ant-Man documentary style.
The quote-unquote answer to this was that you would just jump. Because...
What?
Here's the reasoning. Listen, it never, ever sat right with me either, okay? And clearly Derek in the video is not totally satisfied with this.
You don't have giant frog muscle legs. You got little teeny sticks. Teeny itty bitty ones.
Once again, we're coming down to the square cube law.
Yeah.
And that is your volume decreases, right, by the cube of whatever ratio you're being shrunk. But your strength depends on the cross-sectional area of your muscles, right? How many muscle fibers are all pointing in the same direction together.
Sure. Yeah.
And area decreases by the square. And so Veritasium simulated this with a person being shrunk by about as much as we have them shrink, about the size of an average person. And they simulated a jump, and the maximum height of that jump was 42 centimeters.
That's still pretty good.
It's a huge jump. It would be enough to get over the lip of the blender.
But when you got out, you'd be in the middle of the air.
Yeah, and then you'd fall.
And then you would fall the equivalent of like 100 stories back to a hard countertop, assuming, unless, of course, maybe this blender, because this is totally fictional, is sitting on top of something very soft.
Okay, but it depends on our rules of shrinkage, right? And yes. I think that's all bunk if we're just taking a normal human being and taking all of them and shrinking them down to that size. Because what's not going to change if we do that?
I don't know. There are too many. There are too many postulations.
Is that too open-ended?
There are too many double negatives and took everybody and shrank them down. And then what's
if I take all of you, Trace, and I point a shrink ray at you, and I squish all your atoms to be closer together, some silly how, right?
Yeah.
What is going to stay the same?
What will stay the same? The ratio of the things to each other will stay the same. My teeth will still be smaller than my eyeballs.
I took all of you and I just squished you down, right?
Yeah.
So what have I conserved?
That's our mass.
Your mass.
So I am still the same mass? I could never move.
Exactly. That's what's been driving me crazy.
I'm a 200-pound pinhead.
That nobody's brought this up, right? If you get shrunk down, right? So take myself, average height 177 centimeters down to 1.8 centimeters. That means my volume decreases 950,000 times.
That's a very small volume relative
My
to
mass is the same.
Oh, God.
Density is mass divided by volume.
Oh, no.
Which means I would have a density of 937 million kilograms per cubic meter.
Are you just a neutron star at that point?
I am literally almost the same density as a white dwarf.
Yeah, that seems bad. I mean, so the Google answer is not I would jump out. It's I would pull the blender into a crushed thing around me based on my gravitational pull.
Nothing would be able to support my mass, right? I mean, you'd still be...
I guess you wouldn't really have more gravity at the same time.
Yes, you'd still be your weight on Earth,
exactly.
right? I would still weigh 143 pounds of
raw, sexy man. Just very small. So wait, how do you get out of the blender? You kick the wall of the blender. With all of your force, and it explodes.
It's true. Your punches would be devastating, right?
What?
If it's the full mass of your fist, but with that,
yeah,
the classic 1-inch punch, right?
1-inch punch.
But with all that extra apparent strength.
Yeah.
From your muscle fibers not shrinking the cross-sectional area at the same rate. I don't know. But yeah, so I'd be 64 kilograms, but my feet would be putting that pressure over a teeny tiny area. So if I were trying to walk around outside, I think it'd be very difficult. I think you'd get trapped in the carpet quite easily.
Yeah, for sure.
So
every step, I mean, think of the high heel problem, right? You wouldn't want to be stepped on by a high heel. You want to be stepped on by a snowshoe. This is the same problem. You're going to, every step is just 200 pounds or 100 or 65, 70 kilograms, whatever, of the average person on the size of like a pin, the sharp point of a pin. That's just you trying to walk.
So heaven forbid you're on like a soft surface.
You know, like soil.
Yeah, my high school graduation, they told all the girls in our class, like, don't wear stilettos because you'll sink into the football field when you're walking across it to get your diploma, right? Exactly that. Now all your weight is on a teeny tiny little area. Like if you're walking in the mud, you're just going to get stuck in it.
Yeah, you'll sink.
So good luck with that. You might need to go instead a different route, which is somehow proportionally your mass also shrinks down, which I guess means you're just losing matter. Don't think about what happens to all that matter.
It just sublimates it. Probably smells in the room that you just shrunk in then.
Like a lot of raw meat just being released in the air?
Well, I mean, it depends. Is it sublimating it exactly like into the molecules that it was, or is it going to like atomic level and it's really just a mix of carbon and hydrogen? In which case, maybe it'll recombine and...
Good question.
I don't know.
Good question.
Depends how you're getting rid of the mass, yeah.
If we go this route, Carl Zimmer once again thinks we'd be in trouble because, well, now our brains are not full of all the tasty neurons that help make us so smart.
What? So we get dumber, so I guess it doesn't matter if we get really dumb. Maybe can't even tell our heart to beat dumb, depending on which neurons get
I don't
stripped
know
out.
If we'd be able to problem solve after we're shrunk. I think we're kind of, if we're not a potato from lack of oxygen, we're still a potato from lack of neurons, right? We have 100 billion neurons in our brains as is, and that's the secret sauce to kind of human success as a species. I don't know if we'd be really useful. I think we'd be maybe best case scenario, some tiny, angry, instinctually driven animal that just reacts to like stimuli
and inevitably just gets stuck in a small amount of mud.
Yeah. So thinking about all this, I was like, gosh, could any sort of vertebrate exist at this size, right? Because we know that there are invertebrates that are this small, right? There's insects that are easily this tiny. But could you have something even remotely like us that's this small? So I started looking into the world's smallest primates.
Okay.
Apparently, the smallest primate in the world is Madame Bertie's mouse lemur.
Oh, where's that from?
It's from Madagascar, specifically in the Karindi forest.
Cool.
They're teeny tiny little lemurs with these great big eyes, which makes sense for reasons we talked about. They're also nocturnal, so another reason to have great big eyes. But the average head and body length of adult males is just 4.6 inches, or about 12 centimeters.
Yeah.
Females, 5 inches, so 12.7 centimeters. So they're still much larger 5 to 7 times larger than Aaron's proposed shrink down size.
Interesting.
Right. Now,
wow, it would be like what's a baby one of these lemurs?
I have no idea. I don't have a lot of information on them. They are endangered. They live, again, specifically in this forest. And apparently, a big reason they're found only there is because along with eating, scavenging fruits and like tree gum, they also feed off the excretions of a particular insect that only lives in that forest. Oh. Yeah, this insect sucks the sap out of trees and then excretes it as honeydew, quote unquote, which is a very euphemistic way of putting it.
Yeah.
And the mouse lemur feeds off this honeydew, and so they depend on these insects that only live in this place.
Wow.
Yeah.
Wow.
So they're endangered. There's not a lot of info on them. I don't know how big their little babies are. I couldn't find that. But the adults, full size, still about 7 times too large. So I said, okay, are there any vertebrates that are in this size range? What's the smallest vertebrate in the world?
The smallest vertebrate in the world. Some kind of snake?
Ooh. It is.
Like
it's
salamander,
an amphibian. Oh, yeah.
Axolotl kind of.
You're on the right track. It is the Brazilian flea toad.
Oh, yes, a frog.
A frog,
toad.
Not a toad.
Toad.
It is a frog.
Is it a frog or a toad?
It is a frog. It's a misnomer, which is so frustrating.
Oh, that is. Yeah. Okay. Weird.
I really, really hate it. But yes, it actually took the mantle just like a year ago of smallest vertebrate ever discovered from another type of frog that lives in New Guinea.
Those tiny little frogs are quite, they're 2-3 centimeters.
The adult male Brazilian flea toads are just over 7 millimeters long.
What? That's so small.
Females are about 8.15 millimeters. So you can have a vertebrate that's about half of the length of Aaron's proposed size of 1.8 centimeters.
Wow.
That's insane.
That is so small.
Mm-hmm.
Well, at least we know our back would exist.
Hooray.
Could exist. Not ours necessarily, but
we get to keep our spine. Nice.
Yeah.
Good for us.
Cool.
So they live, as the name implies, in Brazil, and like a lot of small animals, they tend to live in warmer places because
they don't have the
it gets cold
body.
They get cold easy.
They get cold, so they got to keep themselves warm.
Got to retain that heat.
Air.
Mm-hmm. Mm-hmm. And they have some other unusual characteristics that are seen frequently on really, really tiny little animals like this. They've lost fingers and toes. Things that tend to develop late in their development. Really, really small animals lose them, and fingers and toes are in that category. They also grow extra bony material on their skulls and vertebrate, but then lack other bony elements. I don't know why.
Neat.
They are relatives of flea toads. They can have trouble jumping.
Because they're so small?
Because their inner ear structure is apparently poorly shaped.
Oh.
And apparently this leads to trouble jumping.
Got it.
According to Aaron Garcia de Jesus. They have these underdeveloped ears, and it makes it also hard for them to hear songs of potential mates. So they also have a hearing issue, but it's not because of the just straight shrinkage. It's more because, they these structures that, again, happen late in development are underdeveloped. The smallest individual male flea toad that a study has measured was 6.45 millimeters long. And
wow, so like a third the size of what?
Exactly. And that appears to be sort of the limit for vertebrates as we understand it. Anything smaller than 6 millimeters, according to one scientist on the study, says that we'd actually really have to rethink how we understand morphology and physics. So if we ever find something smaller than the Brazilian flea, that could actually apparently change how we think this is all supposed to work. But
Get out there, natural scientist people. Let's find some more cool little teeny itty bitty
Shrink
things.
yourself down so you can more easily find the other teeny tiny toads. Yeah. So
I love
I imagine our diets would be similar. They eat termites, small ants. So if you're shrunk down, if you could digest food, get ready to eat bugs or bug excretions. I hate to say.
Honeydew.
Yeah. Along with foraging, eating fruit that drops down on the ground, or if you can climb, maybe with your little hook fingers. Yeah, you can climb up trees more easily. Be the Ant-Man. But overall, pretty much any way you slice it, it reminds me of, like you were talking about earlier, we didn't develop in a vacuum. You couldn't just take the human form and shrink it down and expect it to work. Like these teeny tiny animals have adaptations that allow them to still survive and be tiny.
Yeah. Cool.
Yeah.
And so to answer Aaron's question, what could he do?
You could try.
What could they bring to increase their odds of survival? Night vision goggles.
Night vision goggles.
Some kind of suit that will keep them warm.
Yeah. Scuba gear. Snacks that hopefully shrink proportionally as well.
Yes.
Friends.
Yep.
To communicate and plan with.
Voice changer. So that you can actually do the communicating and the planning.
That's if you had a shot at all.
That would all help. But
there's a chance you get shrunk down and then just almost immediately keel over because your heart can't pump blood to your brain.
And if that's not the case, and depending on how you were shrunk, maybe you wouldn't even know because your brain would be like...
Yeah. You just become a tiny caveman intelligence person fighting with ants over scraps.
Wow. That Honey, I Shrunk the Kids reboot is really dark.
It's like Lord of the Flies tiny scale.
Literally Lord of the Flies.
Yep,
Take that, flies.
Whoever can harness a fly and ride it around will be the Lord of the tiny civilization.
Take that, Drosophila! All right, well, let's take a break and contemplate eating honeydew. And we'll come back in a minute. Julian, give me your best dinosaur roar.
Oh, God, an asteroid! It's horrible!
Wow, that was not where I expected that to go. We're popping in before the show to tell you about I Know Dino. It's a dinosaur podcast.
We think of those dinosaurs being this thing that's been dead for tens of millions of years. Even so, studying dinosaurs can still teach us stuff that is relevant to the world today.
Yeah, like climate models to help us understand global warming.
Migration patterns of dinosaur lineages, they tell us about Earth's changing continents.
We can also study dinosaur diets, what plants lived then, and maybe what animals and how they interact.
And, this is super cool, many dinosaur injuries, paleopathologies, they're the first known occurrences of diseases.
And they talk about all this kind of stuff on I Know Dino. It comes out every week with new dinosaur stories that you're not going to hear anywhere else. Like, I hadn't heard of a lot of these, which is pretty cool.
You can find I Know Dino on Apple Podcasts, Spotify, wherever podcasts are. And if you found us, you can probably find them. Go check them out. Welcome back to That's Absurd. Please elaborate. We took a very short break, as in Trace and I both shrunk down to 1.8 centimeters tall. We had a fight with an ant colony. We made peace. We married the queen. Well, Trace did. Yeah. And now he's back after siring the next generation. Trace, what is your question for this episode?
What a tale. Someday we'll have to tell the tale of the ant battle.
And subsequent ant love.
Yeah, well, yes, that would be a different book that I would definitely read. My question comes from Meason because Meason won our Patreon poll.
Woohoo!
And they asked, why does speaking gibberish for a second help to fix being tongue-tied?
Oh, this is a Trace question if there ever was one.
He said, I do this and I've noticed many other people doing this too. If I'm finding it hard to get out the words I'm trying to say, I just say, blurg for a second, and that seems to fix the problem. Why? I think I pronounced that word that he wrote perfectly.
Yeah, I agree. I mean, it sounds better in the original German, but...
Yeah, well, yes.
But translated still works.
Yeah, so thank you, Mason, for your question. Speech is cool. I spent a while going on a big old rabbit hole where I, of course, took my aunt spouse, and I figured out speech is complicated.
Oh, wow. This just in.
I don't know if you know this, but speech comes from the brain.
Oh.
I don't know if you know that. Nature 2024 study, an NIH-funded team. They studied the brains of people who were undergoing brain surgery already. So they were awake, and they implanted electrodes on their prefrontal brain regions to capture activity. And the recordings were obtained from, quote, the posterior middle frontal gyrus, in a region known to be broadly involved in word planning and sentence construction and to connect with neighboring motor areas, shown to play a role in articulation and lexical processing. Long story short, they put some bits on their speaky parts. And
when you get tired of writing pre-medial frontal gyral cortex,
yeah.
Speaky bits.
The speaky bits in their brain, in the front of their brain. And people were awake for this, again, which means they could actually talk to the researchers, which is pretty amazing. NIH, good job. They asked participants to say sentences. The dog is chased by the boy. Was one of the examples.
Ooh, and the passive voice? Gross.
Yeah, I didn't really love that. But they did this because they had all these different sentences, I assume, but they really only showed that one in their figure. And I really wanted to know all the other sentences, but they didn't have them. The reason is they wanted to break down the different sentences into their constructive bits. And they found, looking at the neurons, that almost half of the activity had to do with the phonemes or sounds that were used in the sentence. So when you make the dog is chased by the boy, your mouth moves in all sorts of different directions. You've got dog, which if you're making is usually done with the tongue is pushed against the soft palate at the top of the mouth, and you say dog.
Dog.
You kind of have a little pop of air, right? And chased, you have, again, the tongue kind of moves and you go out the sides, and boy, you have the ba with your lips. Your tongue is not involved in the same way. Same as with a P sound. So those different things use different neurons, but about half of the activity in the neurons inside of your brain in the speaky bits have to do with phonemes. So looking at those activities, they could determine in advance of you actually speaking which sounds the mouth was about to make, which is pretty cool. About 200 milliseconds before you actually spoke any word, they knew what you were about to say just looking at your neurons, which is pretty cool. Another 25% of neuronal activity approximately with specific syllables, which is an ordered sequence of phonemes. So you take the word parts, you put them together, you get a syllable. And then another smaller group of neurons dealt with the morphemes, which is like prefixes and suffixes. So in the dog is chased, that ED, adding that morpheme is just an even smaller group of neurons. And then they would activate these in different orders. So first was the morphemes, 400 milliseconds before speech, phonemes, 200 milliseconds, and then syllables about 70 seconds before.
70 seconds or 70 milliseconds?
Yeah, sorry, about 70 milliseconds before.
Okay.
So looking at all those put together, they could determine just how your brain was going to construct a sentence. And, you know, the takeaway here is that basic science helps us understand how the brain does things like encoding speech. And it's not just word to mouth, which is, I think, how most people think of talking. They're like, oh, I think it comes out of my mouth. And it's like, no, there's actually a lot of different, very specific things that the brain is doing to make the mouth and the lungs and the larynx and the vocal folds vibrating with air movement, and the tongue and the nose, and things are opening and closing and vibrating and pushing air. And I'm doing it right now. And I'm doing it all the time when we're on this podcast, and yet I'm not thinking about it at all. Sometimes
same.
Sometimes, yeah, I'm not thinking about what I'm saying. I'm just going.
Brain power is being used in the recording of this podcast.
So the tongue and the lips are moving around and slapping together and stopping air and letting air pass. And all of that is happening in milliseconds between when my brain thinks about it and when it comes out, which is super cool. But that means when things go wrong, they happen really fast as well. So I did a journalism, and I called Dr. Diane Paul, the Senior Director for Clinical Issues in Speech-Language Pathology at ASHA, the American Speech-Language Hearing Association.
Cool.
Yeah. And I asked her what might be going on here.
Sometimes what happens is people may mispronounce a word, they may pause, your thinking gets ahead of your speech, and then your words may sound jumbled or, as Meason said, get gibberish. So we're not fluent. It may be that they're thinking too fast and their words aren't coming out.
And she goes on to say, or they got distracted and the sounds they make help them get over their embarrassment and to signal to others they're still talking. So what ends up happening is maybe, literally, you're just not getting things in the correct order. So as they're trying to come out of your brain and they're trying to go from your brain to all of this complex process that you need to make all of these word sounds, things just get kind of jumbled up. And then you just don't know what and you just go, blah! And that gives you enough time, maybe, to be able to start the process over. We just get ahead of ourselves. And we do this all the time, not in the way of like nonsense words or gibberish, right? We say we say we say like, we say all of these words as filler words, which, we are actually taught not to do when you're doing public speaking, but it tells people that you're still talking. And it gives you a moment to get things in the right order.
Interesting.
Yeah. When I worked at this museum that I don't know if I've mentioned before, but I worked at this museum. And
you worked at a museum?
I did. And I had to give
gosh.
tours to large groups.
Was it like a post-Civil War era like fort on Mackinac Island?
How'd you know that?
When I think of a museum, that's the only thing I think about.
That seems fair. I mean, it's the only thing I think of because that's the one I worked at. They would teach us to avoid saying and things like that because it would keep people from listening. That's what they said. Turns out Diana disagrees. Diane says, well, what it does is even though it does make you sound like you don't necessarily know what you're talking about, you don't know where you're going and what you're talking, it does signal to other people. It's like a signpost, a placeholder, where you're saying, I'm still talking. And so...
It's the three little dots when you're texting that pop up.
Yes.
Hey, hold on a sec. Wait. Just bear with me.
And sometimes there's a longer pause. You and I talk for a living, so we're pretty quick at picking ourselves back up if we trip. But some people, it takes them a minute, and they have to kind of figure out to get back into what they were talking about. And so you need to give people all these little dots. I'm typing to tell people what's happening.
That I can see that. I feel like part of it too is when you're saying people also start panicking. They're like, "Oh no, I'm saying
Yeah.
Oh, what was I thinking? Okay, where was my train of thought? I have to get it. There it is. Okay." And we'll continue. Like along with just getting the sentence sorted out. There's like, "Okay, and let me go through the stages of panic and quelling it, and we're good. Let's go."
Yeah. Maybe. I think that's probably true. I did ask Diane about this.
It could be a placeholder. It could say, you know what? I'm still talking. Let me still talk. I don't think it's a universal kind of phenomenon. I think some people do it.
What if we, again, trying to affect small change on this podcast with our listenership, what if instead of saying, we just have people just go, that's a great, wait. They just yell, wait a bunch. Wait. And then they pick it up like nothing happened.
That's funny.
Wait. I'm thinking.
So Diane mentioned, wait, a few things Wait. So in linguistics, the word placeholder, which she used, is a word that you use when you can't think of the word you actually want. So often it would come up as thingamajig, doodad, doohickey. Those are all considered placeholder words because maybe you don't know the word that you're looking for. ThoughtCo says catigan, a tongue tipper, and a dummy noun would also apply as placeholders. And there's a purpose for those words. We use them to stop ourselves saying or So we add a placeholder. Also within linguistics and in like speech, they have this thing called self-repair. Self-repair is when you do the nonsense word, the gibberish word, or you stop yourself, go back and say the words again. There are different types of self-repair. There's self-initiated self-repair, which is what Meason is talking about, which is the repair, the nonsense word or whatever it is both initiated and carried out by the speaker of the troubled source. But it could be other initiated. So earlier I said 70 seconds and you said, did you mean 70 milliseconds? That was other initiated self-repair because I fixed it, but you did it. I didn't plan
that
it.
the whole
I didn't.
time.
I didn't. It just
you
happened.
Son of a gun. You absolute placeholder.
So you might say, you looked at Mars through your telephone. And you'd be like, you mean telescope?
Telescope?
Yeah. But if you say telescope, that's other initiated, other repair. So you're repairing the thing that I didn't get right.
Nice.
Which is kind of neat. Whereas if you say, what? And I think about what I said and then I fix it, that's other initiated self-repair. If I say, she looked at Mars through her telephone, and then you say telescope, that's self-initiated other repair.
Okay.
So that's
a
the
little
kind of
quadrant, little four squares.
Little Punnett square of this. So it's actually very common in the neurological speech disorder aphasia. Aphasia is a self-repair disorder. It often emerges in connection to word-finding difficulty, word selection errors. This is according to Lasco from 1997. And word finding and word selection, again, are linguistic terms. You're trying to find the right word. You're trying to retrieve it from your brain, put it through the process of turning it into speech, and get it out your mouth. So you might end up thinking, oh, what was the word that I was trying to say? She was looking at Mars, through her, and you just are trying to figure out those words and put them together. This has been in the news lately because of Bruce Willis, who is having trouble with his word finding. He has pretty severe aphasia. And so we know what causes things like placeholders and fillers and self-repairs, but Meason asks, why does speaking gibberish help fix the problem of word finding, word selection, and repair? That's really what he meant. He just didn't have those words to put them together. And he used the term tongue-tied, which actually we use colloquially to mean you can't find your words, but tongue-tied is actually a medical condition. It can be anyway. We use it, again, colloquially, but it's a medical condition where your tongue literally isn't disconnected. It's like tied. You have to have surgery. It's usually people are born that way, but we're talking about verbally or mentally. So gibberish, also interesting word because it's a nonsensical word. So he used the term gibberish, and I looked up the etymology of it because I want to always make sure I'm not offending somebody. We use a lot of words, especially in English, that come from elsewhere, and I didn't know if gibberish was an offensive word. If it is, please tell me. I couldn't find any evidence that it was in my research that I did on it. It might come from Jabir ibn Hayyan, which is an 8th century Muslim alchemist, because his notes were difficult to understand, but there's no evidence of that. It's just one place that people are like, maybe that's where it comes from. Could come from Irish, but it's a nonsense word that's quite popular.
It's funny. I always assumed it was onomatopoetic.
Yeah, and it could be. Nobody really knows the etymology. They have all of these assumptions.
Because when I say nonsense, it does sound like
yeah. So to kind of put Mason's thing into practice, you're speaking really fast, you get in trouble, you get kind of out, and then you resume where you were. And I asked Diane if there was a word for that, because when we're doing science communication, little peek behind the curtain. One of the biggest things that you have to learn when you're exploring something you've never explored before is the language that those researchers use when talking about it. One of the classic examples is, let's say you're doing research on some pharmacological thing, some kind of drug. You need to learn the term mechanism of action, because that is what people who study pharmacology use when they're talking about generically some molecule acting on another molecule and what causes it to do that. You need to look up the mechanism of action. And it took me a while the first time I was doing a drug related or like pharmacological related video to find that word. And the same thing happens when any science communication gets done. And so I had to look up all of this stuff, but I didn't have a word for it. So I asked Diane, is there a word for saying this nonsense word? Here's what she said.
I don't think there is a term. I mean, I guess it's using a disfluency when you either mispronounce or your words get ahead of you. But I am not aware of a name for the phenomenon. Also, it could be word finding. When you can't think of a word, you might fill in with sounds or what you've described as gibberish.
Yeah. So there's not a term, which means, Julian, we get to make one.
We get to make one.
We can coin a term.
Oh, good.
So, Kyle, cue the music. Okay, welcome to Coin a Term on That's Absurd. Please elaborate. Nonsensical self-repair by fake word, NSFW. Is that one taken? Can we use that one?
I think that one's... Let me check the internet and see if that one's used. Oh, no!
What about, you got one? You got a good one?
Well, Mason asked the question, right?
Yeah.
There are plenty of terms in speech where, like, talking about speech errors that are named after prominent people who did them, like spoonerism, right? A spoonerism is when you swap the first sound of two different words, like knuck and futz.
Oh, yeah.
Should I say one in case there are children listening who figure it out? Or
no, it's fine. I get it.
It's fine. Anyway, so this could be a Masonism.
A Masonism? The Meason effect? Meason syndrome.
That's going to make conspiracy...
No, that's just MS. I think that's also taken.
Meason effect is going to make conspiracy theorists lose their mind when
I came up with a few other acronyms. Garbled language interjection triggered by cognitive haste. Glitch.
What's that? Oh, okay.
Yeah. I thought that was pretty good. Spontaneous phonemic idiosyncratic linguistic lapse. Spill. Phonemic syntax error with lingual amendment. A pesla.
What I like, actually, you could have any sort of acronym and it would just kind of look like whatever it is you say, right? If you're just like...
Let's see. BLARG. Let's backronym this BLARG into a bombastic linguistic auto-synchronous repair gibberish.
I love it. BLARG. BLARG.
You could even add a with in there if you want, so it would be BLARG with a W that you don't really hear, but it would be a bombastic linguistic autosynchronous repair with gibberish. If you think of a good name, please tell us. I think BLARG's pretty good. Bombastic linguistic autosynchronous repair with gibberish. It's a all of a sudden linguistic, so telling you what it is. Autosynchronous, which means it's you were having trouble with your speech repair. You could also say auto speech, I guess, which means, again, your speech. Repair with gibberish. I like that one a lot.
I do too. BLARG.
BLARG. BLARG. That's the name of it. It's a BLARG.
It's a BLARG.
It's a BLARG. It's a bombastic linguistic autosynchronous repair with gibberish. No big deal. But anyway, Mason, there's a reason that this helps. It gives your brain time to word find and reset the process from those specific neurons that we mentioned. It signals to the other people in the conversation that you are still talking, you still have the floor, and you would like to finish your thought, and you're doing it with a placeholder word, and that word is nonsensical, and that doesn't matter. Like a linguistic reset. Oh, a spontaneous linguistic unorthodox reset. A slur.
No, stop, no.
That one's not taken, right? We can use that one?
No. You can't. What are you, knuckin' futz? No. Thanks.
That's funny. Anyway, thanks for your question, Mason. That was really interesting to look into, and I learned a lot.
Yeah, and thanks for the patrons who selected it. And I'm glad, Trace, that it was you, because that seemed to be in your wheelhouse. I don't even know where I would have gone with that one. My wheelhouse. Oh, man. My brain is deteriorating.
Other initiated, other repair. Man, learned so much on that.
We're learning.
Thank you, Dr. Diane Paul, for talking to us from ASHA as well. But now, I'm sorry, it's the end of the episode. You're welcome. Or I'm sorry. Whatever it is. Thanks for listening to this episode of That's Absurd, Please Elaborate. The show was created, written, and produced by me, Trace Dominguez.
And me, Julian Huguet.
It was also produced and edited by the wonderful and definitely not blargy Kyle Sisk.
Man who's never made a single vocalization mistake in his life, Kyle Sisk.
Definitely never.
He's built different.
He just is.
Special thanks to listeners who submitted questions featured in this week's episode. That would be Aaron and Mason. If you would like to submit questions, you can look for the form in our show notes. You can email us at hello@that'sabsurdshow.com. You can visit our website, that'sabsurdshow.com/ask. You can call us at 302-TAPE-SHOW. That's TAPESHO.
Special thanks to our new Patreon subscribers. Woo-hoo! Thanks, Silver Skies, for subscribing since we last recorded. A shout out to our absurd administrators on Patreon, Les, Adam, and Austin, and an anniversary thank you.
Yeah, 6
Happy
months.
anniversary, Ashley and Georgi.
Yeah, 6 months of the Ridiculous Researcher tier. Thank you so much, Ashley and Georgi.
Thank you very much. If you want to become a patron, you can do that. Just go down into the show notes. You can see a link there. You can go to patreon.com/that'sabsurdshow, or you can go to our website where you can submit questions. You can become a patron. You can listen to episodes. You can see pictures of our ugly mugs, whatever you want to do.
Or the Madame Bertie's mouse lemur.
Oh, yeah. We can put a picture of that up
Cute
there on our
little lemur.
website.
Do you want to see a cute little lemur, but instead of Googling what I just said, you want to go to a specific website? We can make that happen for you.
We can do that.
Finally, a special thanks to those listening on Nebula. Nebula listeners get access to ad-free versions of episodes. I know a lot of people are saying that ours are also ad-free right now. They may not be for too much longer. And thank you for supporting us and other independent creators. That's really the big part. There's a lot of fantastical creators on there. And if you want to support us and them, you can do so by going to go.nebula.tv/that'sabsurdshow.
We've got some new stuff out on Nebula. I just went to a taping here in New York, Julian. It was so fun.
I'm jealous.
Of a show called Abolish Everything. It's a show that they record at Caveat here in New York City. I'd never been to Caveat. Super cool. They do like the nerd nights and stuff there, but Abolish Everything is like, there's a speaker, they pick something to abolish. One of my favorites from this one was meetings. We just shouldn't have them anymore, which was great. It was really funny. And they have comedians who go at each other to say, like, why are you abolishing this? And they do a presentation, and everybody, it's very fun. You can watch it on Nebula. The first episode is out now. There's other episodes coming out soon. I would love to do one. Maybe I'll get to do one time. That would be really cool. As we say at the end of every episode of That's Absurd, please elaborate. Oxygen doesn't like being the big spoon.
Yeah. Like we always say. But well, that's going to do it for this episode. Thanks for listening, and we'll see you next time on That's Absurd. Please elaborate.
Bye-bye.